All right, everybody, welcome back to chemistry. Hopefully you're doing pretty well. Let's get started today. We're going to be talking about mole ratios and the ratios of chemical reactions. This is stoichiometry part 4. So hopefully you are ready to go. Okay, so first of all, to understand what a ratio is, okay? To understand what a ratio is, we need to look at the definition, all right? Ratio is comparing the amount of one thing to the amount of another, okay? An example here is 400 to 1. So we use this in a lot of different scenarios. Let's look at one scenario that there is a good use for. So 400 to 1 here. When we talk about these ratios, you're looking at the amount of one thing, so 400, to the amount of another thing, to 1, okay? Now, let's say that I want to get a model tank. One of my favorite tanks in history was this guy right here. I'll show you. This is the M4 Sherman. All right, pretty cool. And I want to show off my love for one of these things. Okay, I want to have one of these. Well, I can't fit this in my house. Okay. It's just not going to work. All right. So what I need to do is I need to find myself a model, right? And this model is going to fit in my house. This is just a little plastic model. This, the actual thing, is not going to fit in my house. So this model of this tank is probably, I would say, maybe a 400 to 1 model, meaning that for every 400 centimeters on the real thing, so 400 centimeters on this thing, we'd have 1 centimeter on this thing, okay? So 400 to 1, meaning that there's 400 centimeters to every 1 centimeter on the model, all right? That's a ratio. So we write ratios, that's kind of a tongue twister, with one number colon another number, and that is comparing the size or the amount of one thing to the size or amount of another. Okay, so 400 centimeters to 1 centimeter, comparing the size of the real tank to a model tank. Okay, so 400 to 1. Now, when we talk about mole ratios in chemistry, we'd be looking at something like this, 1 to 2. So for every 1 mole of the red, we'd be doing 2 moles of the blue. 3 moles of red, 2 moles of blue. Don't let that freak you out, all right? I like to think of them as strawberries and blueberries. I've got, for every 1 strawberry, I need 2 blueberries in this recipe, okay? 1 strawberry to 2 strawberries. Now, in this case, we have 3 strawberries to 2 strawberries, right? And then I've got an 80 to 1 here, okay? So for every 80 strawberries, I need 1 blueberry. That wouldn't be a very good mixture, but 3 to 2, 1 to 2, something like that, okay? Really, when we talk about mole ratios, we're looking at a recipe of chemical compounds, all right? 1 of red, 2 of blue. Let's say that the red is O2, okay? And the blue is H2O. Just nice and easy example, okay? So for every 1 oxygen, I need 2 waters, okay? In this example. So let's circle this one. In this example, it's one of these to two of these. In this example, maybe we're comparing the number of ammonia molecules, NH3. Oh, that's a very long tail on that 3. To the number of, let's say, methane, CH4. Okay. So we have 3 NH3s for every 2 CH4s. Okay. So again, we're just looking at a recipe of comparing how much of this we need to how much of this, how much of this we need to how much of that. Okay. Now, we need to be able to do something called calculating a ratio factor. Okay. So we need to be able to do this. Take the big number in the ratio. That's ratio. And divide it by the small number in the ratio. Okay, so for instance, if we have a 10-to-1 ratio, the factor is 10. That's pretty easy, right? 10 to 1. You divide 10 by 1, you get 10. Okay. If our ratio is 2 to 7, then we divide 7 by 2. That gives us a factor of 3.5. Really, what you're determining here is how many times bigger is the big number than the small number. 10 is 10 times bigger than 1. 7 is 3.5 times bigger than 2. And if our ratio is 5 to 8, then 8 is 1.6 times bigger than 5. All right? So, relatively straightforward. I want you to calculate really quick, just in your notebooks, what the ratio factor would be of a ratio that is 17 to 4. Okay, what is the ratio factor of 17 to 4? So pull out your calculators, pause the video if you need to, and calculate that. Your answer should be something like 4.25. Okay, 4.25. That means that for every one of these, we need 4.25 of these, right? So we need 4.25 times more of the first number than we have of the second number. That is a ratio factor. So again, you divide the big number by the small number, and that gives you your ratio factor. Let me show you how that works. So we can apply the ratio factor by determining the correct amount of stuff by applying the ratio factor to the given amount by multiplying or dividing. So let's look at the recipe for a seasoning. Okay, again, we're just going to use simple 2-number ratios here. Okay, now 5 to 11. That 5 represents the grams of onion, and the 11 represents the grams of garlic. Okay, so I already did this for you. We calculated the ratio factor is 2.2. So that means that for every 1 gram of onion, we need 2.2 grams of garlic. Okay. Now, let's say that we have 45 grams of onion. We know that we have that much onion. We need to be able to determine the grams of garlic that we need. Well, first of all, let's look at this. We know that we will always need more garlic than onion, right? Because this is a bigger number than that. Garlic is bigger than onion, right? So we need this much onion, but we need a larger amount of garlic. So we can take our ratio factor, which we determined once again by dividing the big number by the small number. We can take that ratio and apply it here. So what you're going to do is you're going to take the given amount, which is 45 grams of onion. So 45, and you're going to multiply that by 2.2. Okay, so if we have 45 grams of onion, how many grams of garlic should we need? We will need, if you did the multiplication, 45 times 2.2 equals 99 grams of garlic. So we need 99 grams of garlic if we have 45 grams of onion. Okay, now let's look at it the opposite way. We have 27 grams of garlic, right? 27 grams of garlic, but we don't know how much onion we need if we have 27 of these. Well, remember that we will always have more garlic than onion, more red than blue, right? So instead of multiplying by our ratio factor, we are going to divide by our ratio factor. So you're going to take 27, which is right here, the amount of garlic, and you're going to divide it by 2.2. Okay. So if we do that, you should get 12.27 grams of onion. Again, we're going to take our ratio factor, which we calculate by dividing the big number by the small number, and applying it to our known amount by either multiplying to get a bigger number, multiplying 45 by 2.2 to get 99, or if we're calculating for the smaller number, we divide our given amount by the ratio factor. Okay. Now, if we here's a couple of examples. If we have this ratio, okay, this ratio 5 to 2, so 5 strawberries for every 2 blueberries, 5 to 2. That means that our ratio factor is 2.5. Okay, 2.5. When we have the ratio factor of 2.5, if we have 5 strawberries, then we know that we need 2 blueberries. If you have 4 blueberries, you know that you need 10 strawberries. What you do is you multiply 4 by 2.5 to get 10, and vice versa. Divide 10 by 2.5 to get 4. If I give you 5 blueberries, then what we do is we multiply by our ratio factor to get 12.5. Okay? So using a ratio factor to determine the amount of an ingredient or the number of moles of something. Okay? Now let's look at this. This is our equation for the combustion of methane, right? CH4 plus 2O2 equals CO2 plus 2H2O. This is already balanced for you. And this is the mole ratio. 1 mole of this plus 2 moles of that makes 1 mole of this plus 2 moles of that. 1 to 2 makes 1 to 2. 1 mole of that, 2 moles of this, 1 mole of that, 2 moles of that. It's the same thing as blueberries and strawberries. Okay. One kilogram of blueberries plus 2 kilograms of strawberries gives us 1 kilogram of jam and 2 kilograms of juice, something like that. Okay. Now, feel free to pause at any time because you should be taking notes in your notebook. Okay, you should be taking notes in your notebook. 1 to 2 makes 1 to 2. So if we have 4 moles of CH4, 4 moles of this, that means that we need 8 moles of oxygen, right? And how many moles of the carbon dioxide are we going to get? Well, 4 moles of this. The ratio between these two is just 1 to 1. So 4 moles of CH4 will make 4 moles of CO2. And how many moles of water? Well, if we start off with 4 moles of this, that means it's 1, and you compare those two, 1 to 2 again. So you're going to get twice as much water as you put in methane. So you're going to have how many moles of methane? You're going to end up with 8 moles of methane. Okay, or sorry, how many moles of water? If you have 4 moles of this, you'll make 4 moles of that and 8 moles of that. Okay. Now, again, this is just comparing ratio factors. Okay. If we have 25 moles of the red in a ratio of 3 to 7, that means that we take our mole factor, our ratio factor, and we have 7 of this, we divide by 2.33, and that gives us 3. We can, if we have 25 moles of this, we divide by 2.33, and that gives us that. Right? Or if we have 17 moles of the blue, our ratio factor is 2.33. We know that we need a bigger number of red. Given 17.5 moles of this, we need more red. So we take that number and we multiply it by our factor to give us that. Okay. Now, here's one that you can work on your own. I recommend pausing. 4 moles of boron compared to 3 moles of oxygen gives us 2 moles of diboron trioxide. So if we have 18 moles of boron, we have a 4 to 3. Actually erase that X. 4 to 3 ratio. 4 to 3 to 2 ratio. Because 4 moles of this plus 3 moles of that makes 2 moles of that. Okay. So if we have 18 moles of boron, that means that it's going to require 13.5 moles of oxygen, because we take 18 and we divide it by our mole ratio, or a ratio factor. So 4 divided by 3. Oops. Messing up. 4 divided by 3 gives us a ratio of 1.3. 1.3 ratio factor. So what we need to do is we divide 18 moles by 1.3 to give us that. And then if we look at this, how many moles of diboron trioxide are we going to get? Well, the ratio between these two is 4 to 2, which is really just 2 to 1, right? So if we have 18 moles of this, then we know we're going to get half as much of this out. Okay. Now, to the practice problems. So first of all, you're going to have to balance some of these, all right? Just two problems. You're going to need to balance this equation here, all right? So if we are doing H2 plus CO, and that equals CH4O, you need to balance that. Okay? You need to balance this. So how are we going to do this? Well, first of all, you need to balance it. Okay? And then you'll be able to answer this question. If we have 4.5 moles of H2, okay, 4.5 moles of H2. How many moles of CH4O are we going to get? Okay. How many moles? So the question that you need to answer is how many moles of CH4O are you going to get? The way that you're going to solve this is balance the equation. Okay, balance, and then get a ratio factor. Balance and then get a ratio factor. And then apply that ratio factor by dividing or multiplying 4.5 by the ratio factor. So you need to take 4.5, apply the ratio factor by multiplying or dividing to determine the number of moles of CH4O. All right, so that's practice problem 1 for the assignment. Practice problem 2. Practice problem 2 is, all right, you're going to be combining potassium chlorate, or rather decomposing potassium chlorate, so that's KClO3, decomposing it into potassium chloride, and oxygen. And that's molecular oxygen, O2. Okay? So if we want to produce 17 moles of oxygen, if we want to produce 17 moles of oxygen, how many moles of potassium chlorate? So you need to solve for the number of moles of potassium chlorate. Oh man, writing is so hard. Moles of KClO3. Oops, KClO3. Again, you need to balance this equation. So you determine, well, I've got 3 oxygens over here, I've got 2 oxygens over here. How am I going to balance that? Because this is balanced already. I've got 1 potassium, 1 chlorine, 1 potassium, 1 chlorine. How are we going to balance this? So balance it, and then determine your factor, and then apply that factor in order to answer this question. This is question number 2. Okay. Thanks for hanging out with me today, everybody. Hopefully you're having a good day. I will see you again later.